Today we're going to talk about roots. More specifically, we're going to talk about square roots. And we're going to first think about two things that we already know about square roots. Well, usually I get that symbol, and that symbol that means take the square root. You've seen that before. And I usually get something along the lines of that little 2 you see up here. And that little 2 is an exponent. So usually people know that this means take the square root. And then that little exponent means square. So take the square. Okay. We're not going to talk about scientific notation today, so we're going to X that out. But we are going to talk about definitions for perfect square, square root, and the radical sign. So a perfect square is any number that has two identical integer factors. For example, 144 is a perfect square and its two identical integer factors are 12 and 12. A square root is one of the identical factors that creates a perfect square. So the square root of 144 would be 12, so that's the square root. Okay, and the radical sign, this is the symbol that tells us to take the square root. Alright, let's do some examples over on the next page. So the square root of 36, well, we all know 6 times 6 is 36, so the square root of 36 is 6. Right, next one, square root of 2.25. 2.25, is not going to be a perfect square because it's not going to have integer factors that make up the two factors to create this. However, we can take the square root of it. We would have to think what times what gives me 1.25, and the answer is 1.5. So 1.5 squared gives me 1.5 squared gives me 2.25. Next one's kind of interesting. It has a negative sign out in front. So let's do a little bit easier one with a negative sign out in front. If I had the negative root of 36, well, I know that the square root of 36 is 6, but there are actually two other factors, right? I know 6 times 6 gives me 36, but negative 6 times negative 6 also gives me 36. Two negatives make a positive. So when you see that negative out in front, it means take the negative root. So negative 6 times negative 6 would also give me 36. So if I think about this one, negative square root of 1.44, I need to think about what is the square root of 1.44, and that would be 1.2, and then I need the negative version of that. The last one's interesting for two reasons. One, it's got this plus minus symbol outside, and two, it's a fraction. So when you see the plus and minus out front, it means to record both of the roots. So if I see plus or minus square root of 36, my answer should be plus or minus 6. So for a fraction, we want to think about taking the square root of the numerator and then the square root of the denominator. So we can break it up that way. So the square root of 16 is 4, and the square root of 25 is 5. So my answer would be plus or minus 5. Right, next we're going to do a word problem. The infield of a baseball diamond is shaped like a square with an area of 8,100 square feet. Set up and solve an equation to find the length of each side of the baseball diamond. So if I think about a baseball diamond, I've got home plate here, I've got first base, I've got second base, I've got third base. The area of a square is 8,100 feet squared for this particular baseball diamond. We know that area is equal to the square of the side length, and that only works for a square. That formula A equals S squared, right? Length times width, but when length and width are the same, you can just think about squaring it. So we're going to let S represent the side length. So we're defining that variable. Our equation, area equals side squared. But we know that the area is 8,100 feet is equal to the side squared. So to reverse that side squared, we would just take the square root of 8,100. That seems like it might be tricky, but think about the square root of 81. The square root of 81 is 9. So the square root of 8,100 is going to be 90. And you could double check that. 90 times 90, 9 times 9 is 81, and you have the 2 zeros. One from each 90 gives you the 2 zeros right there. So the side length is 90 feet. Right. Looking down here at this helping you remember, we're actually going to skip that because we're going to do an activity about using square tiles in class tomorrow. One other thing before we end, you are responsible for knowing the list of perfect squares from 1 to 400. So we're going to make that list down here. So this is the list of perfect squares from 1 to 400. All right? So perfect squares are numbers that have two identical factors, so we can start with 1 times 1, and that gives us 1. 2 times 2 gives us 4. 3 times 3 gives us 9. 4 times 4 gives us 16. 5 times 5 gives us 25. 6 times 6 gives us 36. 7 times 7 gives us 49. 8 times 8 gives us 64. 9 times 9 gives us 81. 10 times 10 gives us 100, so we got to go all the way to 400. 11 times 11 is 121. 12 times 12 is 144, and that's where most of us kind of stop. But we have to keep going. We've got to get all the way to 400. So 13 times 13 is 169. 14 times 14 gives us 196, I believe. Yep, 196. 15 times 15 is 225. 16 times 16 times 16 gives us 256. 17 times 17, we're getting closer. 17 times 17 is 289. 18 times 18 gives us 324. 19 times 19, we're in the 300s. 19 times 19 gives us 19 times 19, 361. And 20 times 20 is that magic 400. So these perfect squares, I'm going to highlight them for you. These are the ones that you need to have memorized. But really, if you forget, you can just use the same method that we used to identify them in the first place. And that's repeated factors multiplied together. So those are the 20 different perfect squares that you need to be familiar with or be able to recognize.